Practice SAC Part A short answer. Question 1. Which of the following is not a quadratic polynomial? Circle the correct response. A quadratic polynomial has to have a positive real power. So in this particular case, if you look at your powers in each of our options, we have a power of 2, which is positive and real. We have a power of -1 and -2, which is not positive and real. We have positive and real here, and we have positive and real here. So the only one that doesn't fall into the category of positive and real is B, where we have powers of -1 and -2. So we will recognize this and circle this as our correct response. Question 2. Question 2 says to fully factorize the following expression, 16x squared plus 32x. Notice that x occurs in both 16x squared and 32x. So we're going to pull x out the front as a common factor. Also in common between 16 and 32 is 16. 16 goes into 32 2 times, so we can pull it out the front as a common factor. In fact, when we do this, we're going to be pulling out 16x, which will leave us with x plus 2. This is fully factorized, so red box that, and you're complete. Question 3. Expand and simplify the following quadratic expressions. Part A. 4x plus 9, 2x minus 3. In order to do this, we're going to use the distributive property. So it's going to be 4x times the second bracket and 9 times the second bracket. When I multiply this out, I'll get 8x squared minus 12x plus 18x minus 27. And collecting my like terms will give me my end answer of 8x squared plus 6x minus 27, which I will box. Part B. Again, I'm going to use the distributive property. However, the -7 out the front will be the last thing that I'll deal with. So this will go through right to the end, and then I'll expand using this -7. So, distributive property. I'm going to do 2x times the second bracket, and 3 times the second bracket. When I expand this, I'll get out 10x squared minus 20x plus 15x minus 30. Again, collecting my like terms. And then finally I'm going to expand that -7 to give me a result of -70x squared plus 35x plus 210. Each of these questions is worth 2 marks each. So in part A, you would get a mark for your working, and you would get a mark for your answer. Again, in part B, you would get a mark for your working or your method, and then a mark for your answer. Question 4. Fully factorize the following quadratic expressions using the crossover or AM method. AM is the same as AC method that we know. So the first question is x squared plus 11x plus 24. We're going to do this by recognition. So what multiplies together to give 24 and adds together to give 11? Now the two values this works for is positive 8 and 3. We use the positive 8 and 3 and we put them into our brackets, giving us a solution of x plus 8, x plus 3. That is fully factorized. You'll get 1 mark for using a method and 1 mark for your answer. In part B, note that we have 2 as a common factor in 2x squared, 8x, and 42. So our first step is going to be to pull this out the front. When we do this, we'll get x squared plus 40x minus 21. We're going to now factorize x squared plus 4x minus 21. Now in order to do this, again, we're looking for recognition. What multiplies together to give -21, but adds to give 4? The two values this works for is 7 and -3. Writing those into brackets, we'll get 2 bracket x plus 7, close the bracket, open a new one, x plus 3. x minus 3, Mark-wise, we'll again get 1 for the method and 1 for the answer. Part C is a little bit more complex. We have negative 13x squared minus 131x minus 10. Those negatives are a pain to work with, so our first step is actually going to be to take the negatives and pull them out the front. So when I do this, I'll get negative and then bracket 13x squared plus 131x plus 10. AC method says I'm after two values that will multiply to give me 130 and add to give me 131. So the two values this works for is 130 and 1. I'm going to take these two values and rewrite my original expression as 13x squared, 130x, x, and 10. Notice my middle two terms are comprised of the two values that we found. If I now continue this, I'm looking to factorize the first two terms. So 13x goes into both 13x squared and into 130x. So I pull that out and I'm left with x plus 10. I also need to factorize the last two terms, and there's actually nothing in common other than 1, so we pull out 1 as a common factor. Now we're going to take the first term here and the first term here, and this is going to create my first bracket of 13x plus 1. My second bracket is comprised of what I have in the brackets here, x plus 10. That is my end answer, so box it. And what we find is that mark-wise we have 1 for finding the method and 1 for getting the end answer. Question 5. Factorize the following using the difference of two squares. Part A. 49x squared minus 9. Difference of two squares requires you to recognize that you have a squared term at the start minus another squared term. So 49 is the same as 7 squared. So in this particular example, we can rewrite 49x squared as 7x in brackets, all squared. 9 is the same as 3 squared. So I now have 7x squared minus 3 squared. So I have the difference of two perfect squares, which I can now factorize using my rule as 7x minus 3, 7x plus 3. That's my end answer, so I box it in red. It's 1 mark for recognizing your method and 1 mark for getting your answer correct. My second equation, part B, 2x squared minus 32. You'll notice that 32 is not a square number, so straight off we've got an issue. In fact, 2 is not a squared number either. However, 2 does go into the first term and the second term. So if we pull that out the front, we'll be left with x squared minus 16. 16 is a square number, so we'll write this as 2 bracket x squared minus 4 squared. We now have a difference of two squares, x squared minus 4 squared. We can now factorize this using our rule to get 2, x minus 4, and x plus 4. Again, you'll get 1 mark for method, and you'll get 1 mark for getting the answer correct. Question 6. Solve the following quadratic equations using the null factor law. In order to use the null factor law, you need to factorize your equation into brackets. So looking at our equation of 27 plus 12x squared equals 36x, you need to rearrange this so that you have all terms on one side of the equation, i.e. 12x squared minus 36x plus 27 equals to 0. This is not a nice equation. However, what you can notice is that 3 goes into 12, 36, and 27. So I can pull 3 out as a common factor, leaving me with 4x squared minus 12x plus 9 equal to 0. What you can notice is that we have the difference of perfect squares. So we have 4x squared, which can be written as 2x all squared. We have 9, which is the same as negative 3 squared. And in the middle, this can be written as minus 2 times 2x, which is my first value, and 3, or negative 3, which is my last value. So this is a rule that you can use to factorize this, and when you use it, you'll end up with a result of 2x minus 3 all squared. If you did not recognize this, you would not be penalized for it. You could go through and use the AC method and get out the correct response. Now that I have my bracket of 2x minus 3 squared, I apply the null factor law, making that bracket equal to 0 and solving for x, giving me a result of x equals to 3 on 2. I box this as my end answer. Marks-wise, there are 3 marks allocated to this question. There would be 1 mark for your method to factorize. So however you choose to factorize, there's 1 mark there. There's 1 mark for a method to use the null factor law, as that was part of the question. And then the final mark would be given to getting the correct solution. Question 7. Show that y equals 2x minus 2 is a tangent to the parabola y equals x squared minus 2x plus 2. Verify this algebraically and find the point of intersection. In order to show that y equals 2x minus 2 is a tangent to the parabola y equals x squared minus 2x plus 2, you must substitute these into each other. You're trying to get one parabola. So if I take equation 1 and I make it equal to equation 2, so they happen at the same time, rearrange, I'd get 0 equals to x squared minus 4x plus 4. For a tangent to exist, there must only be one solution, i.e., the equation y equals 2x minus 2 will only ever hit the equation y equals x squared minus 2x plus 2 once, and at that point it will be the tangent. So, in order to show this, what we can do is we can show that the discriminant is equal to 0. If this is the case, this is a tangent. So the discriminant is equal to, substituting in our values, 16 minus 16 to give 0, i.e. the tangent does exist. The second part of this question says to find the point of intersection, so the tangent does exist and we now want to know where. So we're going to solve. We'll take that original equation that we created of 0 equal to x squared minus 4x plus 4, and we can factorize this to x minus 2 squared. There's a number of different ways to do that factorization. The quickest is to recognize that you have a difference of 2 squares. We then want to use the null factor law to get x equals to 2. We need the coordinate point, so we need to solve for y, meaning we get y equals to 2, and our coordinate point is 2, 2. We box 2 solutions for this. We box a solution that shows that the linear equation is a tangent. We also box a solution which is the point of intersection. Marks-wise, you'll get 1 mark for showing that that is a tangent. You'll get 1 mark for the method of making your equations equal. You'll get 1 mark for the method of finding the point of intersection, and you'll get 1 mark for finding the solution.